It's automatically cutting the threads and retracting, which is really cool. Welcome to another episode. Today is the first episode where I'm getting the ELS4 basic running the machine. And you'll see that I get to the point where I can do single point threading, and I'm going to cut both a 5/16 18 Imperial thread as well as an M12 metric thread. So let me take you through the process of getting the machine to the point where I can make cuts, and then I'll go ahead and start to make some cuts. I 3D printed an initial bracket, and so the idea is that I want to clamp this on with some clamps, but one of the things that I'm noticing right away is that this is rocking on here, and looking down on it I can see that there's a basically a draft angle here. Here's the second version. I added some effectively built-in 3D printed washers at the 3 contact points so that it can ignore the curve that's in the casting here. It's not held in place really well, as you can see, because I've only got clamps on the bottom. But the idea is I wanted to be able to test this and to see how it's doing. And one of the things I can see right away is that I don't have enough belt tension, which is certainly going to affect things. So I need to do a new version of this that pushes it out a little bit more. But even so, let me just show you that it does work. But definitely the looser belt is going to be an issue. So this is the third version, and so what I can do is, well, the first thing I want to do is I made these holes 4.2 millimeters, and so one of the things that I want to do with them is to tap them for M5. So I've got a spiral point tap, a spiral flute tap, and I'll just visually line this up, like so, and then tap these. So right now this is a 2-point mounting. There's one right here that I'm tapping at the moment, and then the other one is over here, which is the pivot point. I don't know whether that's going to be enough, but that's what I'm starting with. All right, so now I can put this in place. Get the cables out of the way. So this is the pivot point right there. And then here's, on this side, is what allows me to tension the pulley, and we'll see if I've got enough tension on that. Oh, I forgot, I need to put the belt on first, so I have to undo this and put the belt on. Okay, and what I'm noticing, okay, yeah, that's going to be good. So let me get one of the clamps in here, and I want to line it up here. Okay, now I'll put a clamp on the other side. Okay, and now I definitely have, oops, it moved over. So let's see if I can clamp this a little bit tighter. Obviously, this is not the way I want it to be running. I mean, I need to have screws through here to hold this in place. But what I want to do is at least, before milling it in aluminum, just try it out and see if this is okay. Yep, so that looks good. What I'm going to do, I think, is tighten this here. And then tighten this here. And then I know this is not exactly the way it's supposed to be, but let me try clamping it like this. Okay, so that's a little bit more rigid. And that will allow me to see how it is. Okay, that's a lot better. I don't have the full tension on the belt that I want because this is just kind of in a test position, but what this is telling me is that this should be just fine. Now let me try the high speed. Yeah, and you can see it's shifting around because the clamps just don't hold it in place well enough, but what this is telling me is that this design should be good to go. I made a 3D printed jig to be able to mark the locations where I need to drill holes. So I'm going to carefully hold this on here, and then the holes are just large enough so if I go like that I should get nice small spots. And there you are. And there you can see them, the 3 places where I want to drill holes. Okay, that should be plenty enough. So let me tap it. I'm going to reinstall the 3D printed version using these cap screws and test it out before making the aluminum version. According to my guesses, because I'll have 3 points firmly mounted, this should be a lot more rigid than with the clamps that I was using. This is not going anywhere now. I want to get the nut the right tightness, and it has a cool feature, which is this screw on the end is basically a lock screw that goes all the way in. So what I can do is I can get this so that it's the right tightness, and I'll back off the screw and then figure out what is about the right tightness here, and then lock it. That's a little too tight, so that's good right there. So what I'll do is I'll now lock it in place with that screw. And that'll keep the backlash here to minimum. It also means that I can take this nut off, put it back on, and it should be in the same place each time. So that's a really cool feature about these nuts. So what I'm going to do next is reinstall the stepper motor. And of course I have to make sure I put the belt on first. So I'm trying to apply as much rotational pressure as I can to provide some belt tension. And and that has much better belt tension. So let me give it a try, and then fast. Okay, that looks really good. This is the setup, and it's temporary. I need to arrange things a little bit better and mount them up here, but what I've got is an ELS4 basic that is controlling a stepper motor down here attached to the lead screw. And what I'm going to be doing is facing, turning, and then thread cutting, all using this unit. So at the moment I have the cross slide disconnected, but what I'm going to do is get it close and then engage the half nut, and which you couldn't see, but from this point forward I'm going to leave the half nut engaged and do everything else with this box, running the hybrid stepper motor to drive this back and forth. One of the things that I want to do is go into settings and then go to the X motor, and then I want to say that it's not available because I haven't installed that yet. And doing this is going to change the functionality in very important ways when it comes to turning, threading, etc. that I'll show you in a moment. So I'll go ahead and change this, and now that's set. The first thing I want to do is face off the end of the part. And the way I'm going to do this is I'm going to put it into what's called Z-step mode, so I can use this knob to move it left 10,000ths of an inch at a time. So the first thing I want to do is set this to 0.254, which I can do like so that it now moves 10,000ths of an inch when I go into Z-step mode. And you probably heard it move 10,000ths of an inch. Okay, looking at the side, I can see there's quite a bit of gap. So what I'm going to do is, while I'm watching it, I'm going to turn the knob. And that looks like we're pretty close. So I'll do one more, and that should be about 10,000ths of an inch. That's mostly cleaned it up. So I'll bring it back and do one more rotation, notch on the knob for another 10,000ths. Okay, so I have that faced off. And then what I'm going to do is set Z0. Okay, you can see it currently says minus 3.9, so I'll press Z0, and that sets it to 0. And then I'll press Z-step again to take it out of that mode, and now it's saying that it's going to turn going from 0 to minus 15 millimeters, and I want to change this so that it's about 4,000ths of an inch at a time, which is going to be 0.08 millimeters. So I'll change this, and now we're set to go. All I need to do is, once I start the spindle, is press the start button, and it will execute that cycle. So now it's executing the cycle. It's not cutting anything. I just wanted to show you the process. It's working its way down to 15, and then it'll pause. It says now retract, and then it automatically retracts it. The next thing I'm going to do is move the head a little bit to the left so that I can touch off, like so. Okay, so I'll touch off, set the dial to 0, pull it back, and then I can go ahead and start the cycle and put in about 5,000ths. That looks pretty good. So let me make it 10,000ths. That's forming a really nice chip. what I'm doing is when it gets to the end, I back off on the dial just a little bit. And then I can add another 10 thousandths and repeat the cycle. I'll keep doing this until I get to the major diameter for the 5/16 18 thread. Now to measure this, what I'll do is I'm going to use the fast jog to move this to the right. And the advantage of using the fast jog is that it remembers its position. So it knows where 0 is still, which means that when it cuts, it'll come exactly up to that shoulder again. So I want to see how far away I am, and then I'm going to continue cutting and get to the point where I'm ready to start threading. Okay, so that should be enough of a lead-in. And what I'm going to do now is touch off. I'm disengaged the half nut, so I'm just doing this without it. Okay, set the dial to 0. Okay. Then what I'm going to do is get to about Z0. Lock the half nut. That isn't quite where I want, so I'll move it a little bit to the right. Okay, that looks like it's about 0. The next thing I want to do is set this up for threading. So I'll do extended threading. I've set the thread pitch already. This is 18 threads per inch converted to millimeter. So this is the equivalent pitch. And then I'm going to have it go back 12 millimeter instead of 15 millimeter, so it doesn't hit the edge. So the first thing I'm going to do is a scratch pass. So I'm going to press Z0 and then start. If you heard that beep, that was telling me that I was about to retract. And I'm going to go a little bit faster than this. This was 65 RPM, so I'm going to change it to 265. But the first thing I want to do is check the thread gauge. And that looks good. Everything lines up. So I'm going to make it a total depth of 5 thousandths of an inch. Add a little bit of cutting fluid. And give it a go. So I'm now using shallower passes. I've switched to 1/1000th of an inch. So I'm at 24 thousandths. The target is 34, 32. Okay, and then I'm going to check it. So I'll use the fast jog to move it to the right. Clean this off a little bit. And according to my calculations, this should not screw on. It's trying to, but not quite making it. So I'll put this to 34, which was the target. And I can just start it and let it run from where it was. As you'll see, when I press the start, it's moving toward the starting position. Then it's going to pause briefly, and then it's going to start. Okay, that feels good. And no wiggle. It goes right up to that shoulder. And that's really good. And by the way, let me pull this out so you can have a look at what the edge looks like. So what I want to show, let me switch to autofocus. So what I want to show is what this edge shoulder looks like. And you can see that that shoulder actually looks pretty good. I did not face that shoulder. I was turning down to that shoulder. And so I just wanted to give you an idea of how well that works. I think that's pretty cool. So this is my second thread. The first thread that I cut on this, I didn't have the microphone working, the battery ran out. The other thing is I did not cut a relief for the thread. It basically automatically cut it where it needed to. And so, as I say, the advantage is that this will thread up right to the shoulder or the end of the threads. So, success. So at this point I've now cut two different threads. So this was the first one I cut, which was the 5/16 of an inch with 18 threads per inch. And then this is the second one I cut, which is a metric thread, M12 by 1.75 millimeters. And all I had to do was change the setting on the screen of the ELS4 Basic. Didn't have to change any gears, so it just takes seconds to switch from Imperial to metric, and I can choose pretty much any thread that I want. So I'm now super happy with this. This is so much nicer than having to change the gears in the back of the machine. So single point threading this way is certainly a lot of fun and rewarding. It's a lot better than having to change the gears on the machine. And so I'm really thrilled at how this is working. Now, what I showed you here is just a single axis. The next thing that I'm going to do, well, the first thing I'm going to do is make aluminum versions of the mounts for the stepper motor. But the thing I'm going to do after that is set up the other axis. Once I do that, I'll be able to switch the ELS4 Basic to 2-axis mode, and then it will be able to do threading completely automatically, which is pretty cool. It'll also be able to do things such as taper cuts, round corners, etc. So I'm really looking forward to that. I hope you enjoyed this episode, at least as much as I did. Maybe not. Please subscribe, comment below, give me a thumbs up, and if you are subscribed already, you might want to click on the bell icon to be notified when I have new episodes. See you next time.